Okay, if it's okay, so we can start. It's a pleasure to be here once again. Last time we were in November, so I hope you like it, because today we'll have last time when I was there in November, I was talking about cloud native Java and how Java can cope with challenges of current cloud environments. Today, I'm going even a bit deeper because I am probably shouldn't walking around because I'm hiding the slides. The topic of the next presentation today is JVM Iceberg. We need to go deeper. And during that presentation, we'll follow far more topics than the last time. So if you like that presentation that I'm doing helicopter view, I hope you like that one as well. But as we start right now, maybe some introduction. We are from VirtusLab company. VirtusLab is a service company from Poland. We have SOCs and we are also the steward of Scala. So we are responsible for current development of Scala language. Who is currently writing application in Scala language? Or had in the past? Klaus, let's note that. Because that's important information. So we are responsible for Scala. However, it's not my cup of tea because I am the head of the Java Kotlin department, and I'm very happy to be able to talk to you about the modern Java, the very modern Java. How modern I will present you in a few moments. I know that you have presentations like that in the past because I've checked, for example, Nicolas Pyrog was there. I will go even a bit deeper probably, not maybe shallower way. However, there will be multiple topics. How many? You will see in a moment. Let's start with introduction. Who knows that book? Who have read that book? Okay, most of the people, some people, that's the book that is called Programming Programmer. I still remember it's total classic. When I was going to the university, it was around 10 years ago, it was the one book that was suggested to everybody to read. It's probably even a bit older than 10 years ago because you have their 20th anniversary edition and it was published a few years ago. However, around 10 years ago, it was a Bible. Everybody, if you want to be a programmer, you should read that one. And this was a book about how to be pragmatic. It's very, to understand me properly, this is a very good book. However, during that time, I remember that I was reading it with a total cargo code. That I'm now the true engineer, I have 1.5 years of experience, I'm ready. It's time for me, I will be the king of the industry. Because I will be pragmatic. I will be totally pragmatic, I will be doing only what business told me to do, and I will achieve a heaven through that. And you know what? That's probably a solid approach. However, I feel that is a good source of burnout for many developers, because I still remember what is the reason why I decided to join the software industry, because I loved what I did, I loved technology, I loved being on the edge, and being pragmatic is not that compatible with that. I'm saying it because that presentation won't be that much pragmatic. Still, I hope you will like it. That was my interaction from you, because I will have yet another question now. Have you ever seen a format like that? It's so-called Iceberg. Iceberg were pretty popular during the pandemic when everybody was spending a lot of time on YouTube, and this is particular format that is presenting some kind of the topic from the top. We are talking about the top of the iceberg, so things that everybody heard about, so that people who are not very much into particular team are thinking, that's the deep knowledge. And deeper, we are going for something that is truly niche and only for people who are really into given team, given topic. It's mostly done for the pop cultural topics or things like conspiracy theory. If you see on the bottom, the film movie about the conspiracy theory is taking 10 hours. It's wonderful. I totally suggest you to watch it if you have 10 hours to spend one day. I remember watching it through multiple dinners during the pandemic. There are multiple, probably a year or so. However, it's wonderful. It's from, chemtrails. So all the stuff people are talking about are on the very, very top. The things on the bottom, cryptids and things like that. Wonderful. And as I love that format, because I think this is one of the better way to, understand what the edge of particular topic is talking about. I always wanted to make one. However, After some time, I realized I'm not very expert in any topic, so it's very hard to me to create something like that. And then it clicked. I'm pretty good at Java, or at least I'm pretty newsfreak in case of Java. So I decided there's time for me, and I will create Java Iceberg. And during that presentation, we'll be going from the very top. So as you see, things that I hope everybody at least heard about, to the bottom. And I hope it will be pretty nice. How much? I don't know, because there is 100 slides, 140 slides. I don't know how many minutes, because do we have time limit?
No.
Okay, we don't have time limit, so it's all totally depends on you. And during today's presentation, we'll cover 20 topics. So it will be a lot. This presentation, I'm having the slides on each of my presentation because that's true. My presentation is like a cat. It's taking all the available space. So be aware of that. I can do it all day. So we are starting with our first layer. And with each of the layers, I will be asking questions. The question will be the same each time. Okay, who have heard of at least one topic from that list? Okay, so it's probably boring because everybody heard about those, and we should go one level deeper from the Project Panama, Project Amber, and Project Loom. Okay, so the question will be exactly the same. Who have heard of at least one of those projects? Okay, still, most of the people. However, now we'll focus on each. The first one we'll be talking about is Project Panama. And the goal of Project Amber, we are starting with Project Amber. The goal of Project Amber is to explore, incubate smaller, productivity-oriented features of the Java language. Maybe now is a good time to talk, even before we start these 20 topics, let's discuss what projects in Java ecosystems are. Because in there, years ago, when I was joining the industry, like I said, it was around 10, 12 years ago, things like that. Java was developing pretty slowly, because between Java 7 and Java 8 and Java 9, we have multiple years to have anything published. Because each feature of Java, each version of Java was so-called feature-based. It means that particular set of features needed to be done and ready to production to publish the new version. Am I right? Because I'm talking about the history there, and you are there, as you see, 25 years of the JCP. So it was done in that way. After and since Java 9, it changed a bit, because now we have so-called release train. It means that new Java version is published each half of the year. So on the middle of the March, we have new Java version. Then after the half a year, in the mid of the September, we have yet another Java version. And you are blinking and there is no new Java version, because right now, I know a lot of people who thought that we are still in the land of Java 9 and we have Java 21. Because if somebody is not tracking it, it's very easy to miss that there were new Java. New Java is not even anymore most of the time, apart of the LTSs. However, as everybody knows, it's very hard to do big technical initiatives in sprint, and we can treat release train as sprints. So team of the JCP, Java, and all people standing behind the OpenJDK decided, it was initiative that it was even earlier, it's not the new idea, however currently is more fleshed out, that new features will be presented, will be developed in so-called projects. And projects will be delivered through multiple JDK version, and will have some some theme that will just be, umbrella under multiple features. And the first and we'll be discussing few of these projects today. The first of them, like I mentioned, Amber, productivity-oriented stuff. Hello. Okay. And what does it even mean in practice? It means that. So we can we have text blocks, pattern matching for switch expressions, records, local variable type inference. So all that things that truly people care about when new version of Java is released. So new syntax. I could say, have you heard about those features? whoever was migrating to new Java probably has at least seen few of those. I like to describe them as whatever Java can also steal once again, what yet Java can steal from Kotlin, because most of the things are just, people in the OpenJDK are saying we are not stealing anything in Kotlin, it's in the other languages as well. However, you can see it's mostly Kotlin. Yeah, at least from the practical point of view. I need to say, they are doing it sometimes a bit better than Kotlin team, because I think that Java is very well developed language, and whenever you have new feature, it's really thought through. So that's true. However, from the syntax level, probably we are talking about stuff that is already available on the languages and well tested. So we are achieving only stuff that really works. And this is goal of the project Amber. As you see, they are not very connected to each other. We are talking about the new productivity feature, so everything that have direct impact on our daily work. I like to call them a drawer, a drawer, because I assume everybody has drawer like that at home. So the drawer, when you are putting all the stuff that you don't know where to put. When it's not anywhere else, it's probably in that drawer. So this is Project Amber's drawer of the OpenJDK team, especially Mr. Brian Getz, because he is the one that is most involved in that particular project. And to give you an example, last year, probably one of the most interesting additions to the Project Amber was the fact that Brian Getz published the paper that he wants to pave the ramp, so make Java easier for the people who are coming to the language, for example, for universities. And you know, that's standard protocol, so that we have public class, then public static void main string with array of strings with arguments, methods, things like that. It's quite complex, especially for people who are first-time users of any programming languages. It's probably not necessary. So Brian Getz suggested some changes, what needs to be done to start to have Java programs that works that exactly way. And they are saying that they are not stealing from Kotlin. See that. Who is a Kotlin developer, you probably see some pattern there. And after such discussion on the mailing list, on some publication, you are receiving JEPs, so Java Enhancement Proposals. In this case, it's implicit classes and enhancement method. It means that to achieve that, we need to have implicit classes, so something that would encompass the Java code that is not a wrap into any class, so it's added there. And you need to change the starting protocol so that main do not need to be static and do not need to have string array. And it is published as a preview. After few versions of testing, it will be published as a stable feature. That's the standard Java process of releasing new stuff for Java right now. Do you have any question for that? Okay, first one, 19 to go. Just allow me to gulp. Because now we'll be talking about yet another project. This project is Project Loom. And that's the highlight of everything that was happening recently in Java, the one that was definitely the most talked about. Because the goal of Project Loom is to create a high-performance, lightweight concurrency model in Java. And most of what does it mean in practice? Because whenever we are creating new thread in Java, we'll probably maybe to start it a bit different, the stellar of the Project Loom are virtual threads. And to understand what virtual threads are doing and why they are so cool, let's discuss how Java threads are working in Java right now. Because whenever we have thread in Java, we are not Java virtual machine needs to contact with operating system, create new standard operating system thread, that is done by the operating system scheduler, and then use it as a JVM thread in the JVM level. And then it's all exposed to our application. It's something that was working through ages. We'll discuss a bit about the history in a moment, because it's quite an interesting one. However, to have a clarity of the message, they are working quite fine, however have problems. Because so-called OS threads, operating system threads, they are created in their general purpose. So they need to support, video encoding, program, multi-threading in the video games, as well as, for example, calculating of a message for a new request in Java. So they are general used, so they are not fit to any particular purpose. They need to handle all of them. And that's why currently creators of Java decided, okay, maybe there's another approach to that. Maybe we are able to create threads in the virtual machine itself. Because what thread truly is? Thread is a part of the computation that is encompassed with some kind of the control logic and can be done on the different thread of the processor CPU. So probably we can create such block of code and schedule using one of the JVM schedulers in the virtual machine. And now there will be a question, because let's tell me why this block is green here. Have you ever heard about the green threads? What were the green threads? Yeah. Green threads were the original approach Java to the concurrency, because what I'm presenting you now was I would say closely, I can say that it was in the original first version of Java, because that was initial approach to the threading in the JVM applications, because they decided they will be doing threading on the application layer, because it will be quicker. Because whenever you need to create OS threads, they are quite, like I said, unoptimized for Java. Also, you have so-called user space system space barrier that you need to cross. So there's also some additional, cost with switching CPU cores, a lot of low performance stuff. It's better to have them on the virtual machines level. Unfortunately, the initial approach failed a lot, because they were creating totally new language. There was a lot of things about, and the threading was rather it had a lot of problems. So they decided that since Java 1.1 and 1.2, probably 1.1, they will just use the standard abstraction operation system threads. And so-called green threads, where they get rid of so-called green threads. After the 20 version of Java, we are ready to return to that original idea. So now threads are once again created by the virtual machine. The project Loom most of the time is associated with virtual threads, and people are thinking it's exactly the same. It's not exactly true, because in the project Loom there's a bit more features, like for example scope locals, so replacement for the thread locker, because as we won't have standard threads, we will probably need to approach the topic of the thread locals a bit different, because there's approximation that if we are able to create threads on the virtual machine level, we are able to create millions of them, because they are just part of the code with a particular part of the stack. It's not exactly true, because each of the threads needs to be associated with a part of the memory. So we are limited by the initial how hardware we are running it on. However, still it's quite nice way of scaling our application and being able to just cheaply create threads. So all that reactive programming stuff, probably the so-called callback style, so using the computable future, there is a promise that it won't be necessary in the future. Okay, future won't be necessary in the future, nice one. Okay, and this is one thing, scope locals. They also need to be lightweight, because we have lightweight threads, we need to have lightweight thread local. Also, there is structured concurrency, because if we even have that million of threads that they are promising us, we need to have some mechanism to control those, and structured concurrency is used as the idea to work with that. It's a bit similar to what Kotlin proposed. It's currently in the preview. However, Java decided to use its own flavor, and it will be did with a construct that is really similar to the try-catch blocks. So, for example, when the particular block will end, all the child threads will end as well. It's quite interesting context, probably outside of the scope of this presentation. Okay, so we are talking about the two first projects. Do you have any question about Loom? Like I said, it's a pretty helicopter view still. I think it's clear what Loom is bringing. Any questions?
Project Loom is implemented in which Java version?
Project Loom virtual threads are available right now since Java 21, which is LTS. So those things you can use in the production. Okay, like I said, I have all the time in the world, so I can go side notes, yeah? And currently virtual threads are implemented in the new version of Spring as I don't know if it's test feature or their real feature, however, they're starting to experiment with it. All the other frameworks are experimenting as well. There's also implementation, for example, in GraalVM. So we are doing the first experiment with that. Probably the most interesting approach currently, the broadest one, is so-called Helidon Lima. So framework that was written from scratch just on the virtual threads, and they replaced Netty because they initially run on Netty. Now they replace it fully with the virtual threads. What is Helidon? We'll be talking about a bit later because we'll have it on our Iceberg. So yes, virtual threads are production ready right now. Just we need to wait for the whole ecosystem to be ready to consume them. Okay. Project Panama. We are going to the next one. The goal of Project Panama is to simplify the process of combining Java programs with non-Java components. And once again, we'll use my totally professional, not made in PowerPoint slides, because yeah, I'm just using standard shapes. They are not, oh my god, they are not even centered properly, as I see. However, I hope it's probably enough. Legacy, once again, operating system, JVM, our application. Whenever we are talking about, operating system has its own memory, and in contrast to what we presented during the threads, Java is not using memory, not directly using memory of the operating system. Java is using managed memory, that is managed by its own. In that situation, we are talking about that Java has, like I said, its own, after starting the JVM, they are allocating a bit of the memory, and then that memory is used by Java application and it's controlled by our garbage collector that is cleaning it, and we are able to we have security features, like for example we cannot have segfault exception or segmentation, so-called segmentation faults that were quite possible in C, because our virtual machine is a security layer for that and is doing checking all the constraints. However, the problem is that it's pretty slow, especially for the application like databases, like applications like event streaming, all those stuff that probably should just read raw memory and create, for example, consume the so-called mem pages, not only use the memory that is consumed by the JVM, because there's an additional abstraction layer and it's always slower than just using the raw things. So, for years in Java, there was two approaches to that. The first one, whenever we wanted to have a safe application, we are using managed memory, and if somebody wanted to be quick, they used something that shouldn't ever be used, so-called sunmisc unsafe package. The unsafe in the package name probably is saying something. So sunmisc unsafe was used, it was the class that was used by the JVM itself to do all that very quick stuff that needed to have access to direct memory. However, people learned that it can be used, and it was used. It was used by the project like Kafka. Okay, probably I'm right now, because on some version, in some time in the past, it was used by Cassandra, by Kafka, by each of the DB project that was written in Java. However, it was possible because there was access to that class. Because for years, Java, everything that was available to the JVM was available to the application developers. It changed after JDK 9. And the reason why we waited so long since from JV8 8 to JVM 9 is that they wanted to create modularization and encapsulation. So they wanted to, during the project, so-called Project Jigsaw, they wanted to just hide some international implementation details of the JVM. And whole community said, you are just killing me with that, because we won't be able we will never migrate to the new version of Java if you just hide access to the sandwich unsafe, because it was used by the, very important project in the community. So architects of Java, if I remember from Mike Reinhold, agreed that there will be compromise. So sandwich unsafe wasn't hidden. However, until they will provide new API that would be useful for the developers who would like to read the internal memory of the operating system. Because there is JNI, however, JNI, who has even written the program within JNI? What are your experiences? Do you like it? Okay, so we have the first guy ever. I need to talk with you later. Yeah,
but it was 20 years ago.
Okay.
I was using some library which were available for C bindings, and to use this, I used JNI.
Exactly. However, it was okay. However, writing the big piece of Java JNI application was very pain. The compilation, the toolchain support for the JNI was pretty bad. I don't want to do bad. It was pretty complicated. That's probably the best word there. And people didn't like it at all. So Project Panama provided the better way to support Java application. Because, some memes there. Because, whenever you are using the managed memory, you had, big hack from the virtual machine. Whenever you are using sandwich unsafe, everything could happen. Everything wrong could happen in the situation. So we were told that we'll be able to receive the type-safe memory API, type-safe API to read and write the operating system's memory, and that's so-called foreign access memory API. It will be delivered in the next version of Java, JDK 22. It has constructs that are created especially to be able to communicate with the operating system memory. And not only that, because also ability to communicate with all those external C programs, currently just C. So Java developers do not need, to do multiple hops just to be able to communicate with everything else in the world. Because it's the reason why, for example, Python is such popular, or Node.js was such popular, because it was very easy to use C application with Python. The truth is that Python is used for machine learning. It's bullshit. Python is just the application layer, and everything beneath is just plain C. And this is the same idea that it will be also possible in Java. Currently, like I said, both foreign access memory, foreign memory API, and foreign programs, foreign application API, it's called probably like that, are ready, newly ready, because they will be ready in March this year. And next interesting step for the JVM developers is multi-threading, multi-CPU, just GPUs, multi-core processing units. Because currently, it's very heavy to use the power of the GPU with standard Java application. Because there is Tornado VM. Tornado VM is a fork of the Graal VM, which we'll be talking about in a moment, However, it's the fork, and they are currently working in the panel, and they don't have a standard API to use with something that has, for example, thousands of cores. Currently, they are working with Project Panama to create such an API, and it will be probably delivered in one of the next version. It's also a bit connected to called Project Babylon, but Project Babylon is probably that early stage that it will be outside of the scope of this presentation, maybe next time. If I have opportunity, I will be talking about the Project Babylon, because there are some interesting things happening in that topic yet. Probably question all the stuff connected to the foreign active memory interoperate with C would require yet another presentation. We don't have that much time, and I'm not that ready. Okay, so that was the first. We are beneath the first layer of our iceberg. Do you like that style? Can we go deeper? Okay, so we'll go deeper and we'll be talking about the project Valhalla. And why, whenever, okay, after the initial switch to the release train model, there were 4 big projects announced. Project Amber, Project Panama, Project Loom, and Project Valhalla. Do you know why Project Valhalla is 1 level below than the 3 other on my Iceberg? Because 3 other projects we were already heard about or see some results. With Project Valhalla, not that much, because they are iterating. They are iterating a lot, and they are switching. The Project Valhalla are switching their approaches all the time, because they want to do it everything they need very properly. That's the Java style. And what they like to do, they want to change how memory works in Java. So they are doing a lot of very interesting stuff. Once again, my picture of the JVM. It's till probably block, our till block. So our Java memory is also, we need to split, we are splitting it to some parts. For approximation, we can say it's stack and heap. So yeah, I know it's very approximative approach. However, for the project Valhalla, it will be probably enough. And on the stack, we are storing so-called primitives like chars, float, integers. So all those primitives, small code ones. And on the heap, we are storing objects. In practice, it means that whenever you are creating object and you want to access it, you are not accessing it directly, because you are not accessing it using it from an application to the heap itself. However, most of the time you just have so-called reference that is stored on the stack, and then a reference knows when in the heap the object is, and is able to return that object. So we are doing yet another hop. So yet another abstraction, and as you know, it's pretty expensive. It's especially expensive whenever we have very complex objects. Because let's see on this example from the original Valhalla paper, or one of the Oracle documents. For example, we have class that is called landmark, and that class has reference to its own address in the memory in the heap. It has name that is string. No type of chars, that is string in the situation, and go location that is yet another object. Whenever we are retrieving that object from the memory to reference, we need to follow yet another reference and yet another reference to collect the whole tree of objects. For the Valhalla projects, they want to create a special kind of the objects, so-called value objects, that will be able to retrieve everything like this through the single reference. So we'll be able to just make one hop and retrieve everything what is needed, because it will be stored in memory in the special layout that will allow us to do that. Because what we are losing in that situation, we are losing identity of the object, because what is the source of all that? Because we know that this object in the situation has its own identity that we can, for example, compare. This object has its own identity that we can create hash code for it, we can create equal for it. We can treat, for example, something that has the same latitude as a different object. It won't be the case in the value object, because everything inside will be automatic there. And that means, and one probably very interesting insight of Valhalla is that the identity is not always that important. Sometimes we just need to treat our object as a standard values. And Valhalla, goal of Valhalla is in the first step, is to create a single reference to value object that will be stored on the heap. And on one of the moments when Valhalla was developed, there was or is the plan that value objects will be stored on the stack as well. Right now, I don't know if they are still so into it, because like I said, Valhalla is iterating a lot. However, that's the major idea behind the project Valhalla. We can treat our value objects like kind of the data upgrades. It's very important project, because that model allows Java for very interesting use cases that were not previously, that Java was not feasible for, like, for example, machine learning. because machine learning is working on a lot of very small objects. Not very small objects that probably we want to acquire very quickly. And in that situation, Valhalla is very helpful. There is, of course, a lot of different cases as well. It means in practice quicker access to the memory in Java. That's why they are iterating a lot, because we are talking about the core of Java in that situation. Actually, they are also thinking about the fact that primitives should be able to be used in generics. In generic, also value objects should be treated exactly like primitives. There's a lot of different approaches. Probably the most interesting one is that Java is introducing the aspect of non-nullability, because they tried to create the least common denominator of between primitives and value objects, and they learn, okay, probably something that took them into account. If we get rid of identity and we get of the null value for value object, because value objects probably you won't be able to have null because you don't have identity. So it's not possible to have null object in that situation, because it's not work that way. So they decided that, for example, they probably need to bring non-nullability, that non-immutable, real immutable objects to the Java virtual machine. It's a lot of interesting things happening in Valhalla, and I hope we'll see at least some of them in 2024, because it won't happen in the first half of the year, because we already know what will happen in March. However, for the September, there are already first jobs that are targeting, that are referencing Valhalla and referencing value objects. We don't have any directly Valhalla one. However, one of the Panama is already referencing the Valhalla and value types, and it's already targeted, so probably something is happening behind the scenes. So I hope that this year will be the year when we'll see the first version of Valhalla as well, at least in preview. Okay. Let's carry on. Okay, we are here. Okay, let's carry on, because we are just starting. Now we are going to the even more interesting project, because we are talking about the GraalVM. Have you ever heard about the GraalVM? Who have been using GraalVM? How do you like it? Okay. We definitely need to talk after the presentation, because there are multiple interesting experiences. But I agree, your mileage can vary with GraalVM, because there are some different flavors of that project. However, what GraalVM even means? It means one virtual machine to rule them all. What does it mean in practice? To understand what GraalVM is, let's focus on what JVM is. And JVM is the Java virtual machine. Java virtual machine is the runtime that is powering everything that is happening in the Java language. So it's what allows us to run our Java application in the production. It's a virtual machine. A virtual machine, so that additional program that can run our application. However, Java virtual machine is such a good piece of engineering that is not only used by Java, it's also used by different languages, which in practice, probably I wouldn't like to tell that amongst people from JetBrains. Do we have anybody from JetBrains? Okay, so sorry for that, but Kotlin, Scala and Groovy, they are probably a bit of, we can treat them as a syntax sugar over just Java programs, because they're compiling to the standard bytecode. Whatever is happening on the Java virtual machine does not even care what language was it written in. Yeah, so we have Kotlin, we have Scala, we have Groovy. I love Kotlin a lot. So in that case, I think it's a very good language. However, like I said, both Kotlin, Scala, we are steward of Scala, Groovy. We can treat them in the simplification as a syntax sugar over what is happening in the bytecode later. And GraalVM is extension of the idea, because if we have a single virtual machine that is able to run multiple languages like Java, Kotlin, Groovy, Scala, probably we are able to create virtual machine that is able to run all the languages. And this is, ladies and gentlemen, we are talking about GraalVM here. Because GraalVM is a project that was originally fork of the hotspot, so standard Java virtual machine, and its goal was to run different languages and be able to create some interesting piece of engineering that allows to use all those stuff you are seeing on the screen. So Java, Ruby, Python, C, Scala, Groovy, Rust, JavaScript, C++, and many others. It's compatible with OpenJDK. It's, for example, can run Node.js workloads. It's embedded currently in the Oracle database, and this is a very interesting piece because, like I said, GraalVM supports JavaScript, and it's embedded in Oracle database because it is used for writing the JavaScript triggers for database functions. So you can write a piece of JavaScript that will be run by GraalVM to do something with your data in Oracle database. I dare you in that situation. It's exactly the same with MySQL because MySQL is currently rather compatible with some features of the Oracle database, and it also allows us to create a standalone application that will be just run as a standard program. And far more. This is just an example of what GraalVM can do. And how it's even achieved. Because they achieved that through pretty interesting engineering, like I said. Because, once again, simplified view for the JVM. JVM contains those pieces. We have bytecode interpreter, so that part that is interpreting bytecode, because whenever we are compiling Java application, we are compiling, in the initial stage, we are compiling it to so-called bytecode. And that bytecode is run on the virtual machine, interpreted because it's interpretable code. And after some time, when virtual machine decides what is good to be compiled to the machine code and what is not, and on which level, just-in-time compiler is run. It's a compiler inside the virtual machine that is compiling that part to compiled code that is very efficient and on the C level, I can say. I can probably say that it's on the C level. It's how JVM virtual machine works. GraalVM is working in a bit similar way because on the bottom we have so-called substrate VM, which is very thin layer of the virtual machine that is bringing all the basic functionality, connections with the operating system, things like that. And we have just-in-time compiler, and this just-in-time compiler is able to compile code to the machine code. However, there is one interesting piece that not many people are talking about, that this compiler is swappable. What does it mean? It's once again simplification, because everything in that presentation is simplification and they are very complex projects. However, you can imagine that you can take your just-in-time compiler from your environment and switch it to the just-in-time compiler for a different language. For example, you are compiling Java code, and then you are using just-in-time compiler for Ruby to compile a bit of the Ruby code. So currently, on the GraalVM runtime, you are able to just mix different languages together. During last GeekCon in Prague, for example, there was a guy from the GraalVM team who was presenting how Python is interoperable with on the GraalVM. It was a very good presentation. It was the first time I've seen a presentation like that. It was pretty nice. Currently, all those languages are powered by so-called Truffle framework. So this is framework for writing languages, I would say JIT compilers, languages for the GraalVM. It's so-called Truffle. And they are able, like I said, to be distributed external to the standard runtime of the GraalVM. Currently, you download them as a standard Maven dependency. Because to have them in your final binary, you are just having them as dependency. So they're totally independent of the virtual machine. And why is that so cool? Because let's discuss how we create applications today. Whenever we have our operation system, we have our application, probably we have operation system, which is one container, we have JVM, and we have our own application. And it was created, the question is, why do you even want to have virtual machine? What is the reason to have virtual machine?
Write once, run everywhere.
Exactly. And that was exactly initial promise of the virtual machine. And then there comes the question, when was the last time when you didn't know on which environment application will be running? I assume you will just shake your hands up. However, not. Because most of the... Yeah, okay. So we have people, but no that many of us. Because meanwhile, we are defining our environment from scratch. We are using terraforms of the world. We are putting our application in containers. We want to have everything as code. So most of the times, we know pretty well what will be our environment. So all that additional layer, that layer is not only for write once, run everywhere. Okay. It's Vora, not Vera, or Vora. Yeah, run everywhere. So anywhere. Okay, I remember that the shortcut is Vora. So write once, run anywhere. It's not that necessary for every use case. And then comes GraalVM, because if we have our just-in-time compiler that is external to the virtual machine, and we are running our application to Kubernetes, and we perfectly know what operating system will be that and what hardware will be that, probably we can use that compiler ahead of time. So we can compile our bytecode before in the process that works exactly as just-in-time compilation. Maybe not exactly, because there are some tweaks to that, because just-in-time compilation is not doing only standard compilation. It's delayed because it should be delayed, because it can do additional optimization just because it's run after some time. It, for example, know that particular method is always used with exactly the same parameters, so it can do additional aggressive optimization that is not possible ahead of time. But for the most application, compilation ahead of time is enough. And through using that JIT and just-in-time compiler that is external to our application, we are able to create final binary that will have all the optimization from scratch and can, for example, be run or our Kubernetes without virtual machine. So we are getting rid of the virtual machine. And that's the main optimization of so-called native images. Because native images are not the only part of the JV, not the only part of the GraalVM, however, the one that we achieve when we use just-in-time compiler outside the runtime. And it's possible with everything that is happening in GraalVM project. For years, GraalVM project was delivered into version, Community Edition, Enterprise Edition. It's changed first in 2022, where GraalVM was announced to be, that it will become the part of the OpenJDK. So they decided, because for years the adoption was skewed a bit, because each part is created by Oracle, and probably everybody is a bit worried with using anything that is published by Oracle without the lawyer, and it's hard to add lawyer to the Agile team. You understand probably that. So there was some price. However, currently, Community Edition, which is totally fine to use, that the truth is that it was always ready to use, will become the part of the OpenJDK through the project that is called Project Galahad. I love the name, because Galahad was the knight of the King Artur that brought Graal to the Camelot in one version, or somewhere else to the other. It's depending who you believe, or you not believe anybody, any author at all. However, Galahad was one that was always involved with Graal, so it's how they named the GraalVM project Galahad. Interesting stuff, something that I learned on the GeekCon when I was talking with the GraalVM team, because I have opportunity. Do you know why logo of the GraalVM is rabbit? Because of the movie Monty Python and Holy Grail, and the rabbit that was the beast there. So they are truly geeks, and I love it. Yeah, so it's based on the Monty Python and the Holy Grail beast that was rabbit from that cave. I don't remember what exactly is that. So they are using that reference all the time. The other version of GraalVM is so-called GraalVM Enterprise Edition, and Enterprise Edition is the one that was published by Oracle using their own license that was quite complex. So the truth is, it was the best to use it in Oracle Cloud. Currently, they are renamed the GraalVM Enterprise Edition to Oracle GraalVM, and is currently supported by the license similar to the Oracle JDK. So if you are on the edge, so always using the current version, you are probably free to use it all the time. Still, to use Oracle GraalVM, I suggest you at least contact with some kind of the lawyer, because you know it's for Oracle. It's best to approach it that way. However, as far as I was discussing that with GraalVM team, it should be fine, but they are not. Please read the license surely with lawyer, because it can be kind of hard. GraalVM C, so Community Edition, is ready to use and perfectly safe. Okay, oh my god, we are not even in the half. What time is it?
5 to 8.
Oh my god, it's an hour. So like I said, I'm using all available time. I hope you have a long evening before you. Because we are now be talking about the Jakarta EE. Who have ever used Java EE? Me as well. And you know, what's your opinion about the Java EE?
Great. Was great.
I like the project. I remember the bad raps of the Java EE, and I used it in the first project, and I loved the experience. It was very good. However, after some time, Oracle decided that probably they don't have resources to support it as an internal project, and they decided that they will just return it to community. And it's your problem now. And it was adopted by Eclipse Foundation. And Eclipse Foundation decided that they will be support it in the future. However, you know, Oracle is quite unique company. And please, if somebody from Oracle is watching it, don't sue me and don't be offended by memes. I love you. I truly love you because you are doing great work. However, that's how your company structure looks like. So for those who don't see, this is legal, this is engineering. This is approximation, however, probably close one. So whenever they decided to return the calls to the community, they decided that, okay, we'll give you all the technical compatibility kits, or the classes, or the runtimes, everything that is valuable, apart of the name, because Java is a trademark. And if you have trademark, you need to protect it. And Oracle decided that, okay, you can have that project, however, you cannot call it Java. You cannot use the name Java anywhere. So the project is now called Jakarta EE. And there's one yet additional problem. Have you ever heard about the package that is called JAVAX?
Yes.
What word is inside the JAVAX package?
Java.
Exactly. And that was the problem, because as this is everything that had Java name in their code base was under the trademark. If the community wanted to do anything with that project, change any class of it, they needed to migrate to the new namespace. And JAVAX package is everywhere. Each of the web framework, each of the popular libraries is using JAVAX because it was, for years, it was standard. We'll be talking about it a bit moment later, probably. So it took few years to just do anything valuable with Jakarta EE. What happened, meanwhile, we'll be talking about it in the moment, because like I said, this presentation is quite long. However, to focus on the topic of the trademarks, there's some interesting stuff as well. Because, for example, there is Adopt OpenJDK. You have JCP community in April, so Adopt OpenJDK is one of the artifacts, probably you can say that. Okay. Adopt OpenJDK it was the initiative after Oracle decided to return OpenJDK also to community, and both Oracle JDK and other. We needed to find a way to create new version of Java from the source code, because it's not just easy that everybody will be compiled their own version of Java. You need to have pipeline, you need to have a test, you need to have the whole ecosystems for that. And there was an initiative that was called Adopt OpenJDK, and it was driven by the JUGs, and was JUG Munich involved into the Adopt OpenJDK initiative. I know that London was, for example. However, okay, Munich wasn't. So a lot of devs decided, okay, we'll be supporting it. However, it was unsustainable for a longer time, so now it's also part of the Eclipse Foundation. And it was quite similar problem, and I tried to confirm if that's the myth or if that was the true. I was talking with people on the Eclipse Conf if that, legend is true, and they didn't know. However, I find it quite funny. So I heard the legend that the project of the OpenJDK, due to the trademark, needed to change the name to Adoptium. And the official, the most open version of the OpenJDK that all of you should use is called Temurin, to make everything easier. Because this is the most open Eclipse supported version of Java. Whenever you are C on your Jenkins machines, on, for example, on IntelliJ, something called Temurin, it means you are having the best version of Java possible. It's just, to be easier, it's called Temurin. I even remember, one time I've checked what was the source of that name. Yeah?
It's runtime.
Runtime, yeah.
I never get it. What's the difference between Temurin and OpenJDK?
OpenJDK is a source code, and you have different runtimes of the OpenJDK. You have one from Microsoft. Microsoft has its own compilation of the OpenJDK. Yeah.
I can download an OpenJDK. I can download whatever version.
Which one? Okay. So which version of OpenJDK? You can use different version of OpenJDK.
21, for example.
21, for example. You can have 21 Java from the Microsoft. It's called Microsoft OpenJDK. You can have one from the Eclipse Foundation. It's called Temurin. You can have one from the Azure. It's called Zulu. You can have one from the Amazon. It's called Coreto. Then you can have one from Oracle. It's Oracle JDK. Each of those.
One from OpenJDK.
Yeah, they are all using exactly the same, nearly exactly the same source code. They are just ones that, they're responsible for creating the binary, signing it, adding all the patches, all that process. So that's the one process, the process of creating new version of OpenJDK from the Eclipse Foundation is called Adoptium, or that pipeline of creating it, and runtime itself is called Temurin. Okay. So this
we should always use the Temurin.
Yeah, probably is it's the most common one. It's something you probably, if you are going with Temurin, everything should be okay. Yeah, smooth. Yeah, because it's the most open version, I would say. It don't have any additional features that are outside of the OpenJDK, because for example, Zulu from the Azure it has, J9 have some additional tweaks, because it's one from the IBM. That's also, the fun part is that Eclipse has two versions of the OpenJDK, because it's Temurin, and this is J9. J9 was alternative version that was created by the by the IBM, and Temurin is the one that is the most popular one. And to make it even funnier, there was, in 2022, there was open letter from the Ryan Dial, creator of Node.js, urges Oracle to release JavaScript trademark. Because, JavaScript has one word that is a trademark here, and the truth is the most popular language in the world is not called JavaScript, it's called ECMAScript. The standard is called ECMAScript. And JavaScript is a common name. It cannot be used in any official documents because it's just the common name, because it has Java in name. The official language is called ECMAScript. But everybody is using JavaScript, so creator of Node.js urged Oracle to clarify the situation. As far as I know, there was no response to that letter. There is even funnier stuff, that there was a project that was called Rust for JavaScript Developers, and it was received cease and desist form from Oracle due to JavaScript trademark, and it was 21 April of 2023, when so quite fresh. And Oracle decided to just fight for that trademark because project Rust for JavaScript developers use it. So it's truly happening, and be careful with using JavaScript name because it's in ownership of Oracle. And the problem of them was that they wanted to create the real company from that, and I see this just Rust for JavaScript Developers Ltd. I've never heard about the problem. There was one problem with Java library. It was so-called Java slangs. So it was bringing all the functional features to Java. It was called Java slangs, and it had received the suggestion from Oracle that they should change name to Vavr. So it happened in the past. Whenever you are using Java as the official part of your whenever everything that is commercial, probably you should be very careful. Okay, that was the second layer. We are going deeper, and we have to another topics once again, because we are talking about Java EE, and Java EE had multiple phases. When Java EE was initially created, so Java was initially created of the language, then they decided probably it's good to have something to make it easier to use by enterprises and create all those enterprise features. Enterprise features are like Corba, like some kind of, not dependency injection because it was a bit later. However, all that enterprise features that enterprise needs at the particular time. The time was when our application was run. Application servers runs like that. It's original picture of the Sun server from 1999. I found it in Google. I've never seen it in the real world. However, yeah, that's how the application servers looks like in 1999. However, you know, Java EE for years were known for that. Okay, it's the old standard. But to understand how old, we need to remember, we need to see that it has already went through one iteration, because original name was called full profile, so it had everything. But after some time, Java EE decided, okay, we need to modernize ourselves, and they decided to split all the internal features from into two different projects. The first one for the full compatibility was called full profile. So everything from the 99 is there. And the other project was called web profile for the modern web application from 2009. Because what the first iteration. And in practice that means that full profile is that nice monolith from the Kubrick's movie. And from our perspective, web applications, so VARs, all that are properly commonly used, are those small monoliths. They are still pretty big in our situation. They still require the application servers, things like that. So it's not something that we probably don't want to use technologies from 2009 and standards from 2009 in 2024. So as like we already mentioned, there were some problems with doing anything sensible with Java EE due to the change of the name and the trademark issues. The initiative that was called Microprofile was created. And Microprofile decided, okay, there are few very interesting parts of Java EE that everybody is using. Like, for example, CDI, or JUG, or for example, Java annotation. So all those stuff that is pretty popular, we probably shouldn't rewrite it. We can reuse it because it's open. We can just migrate it to the different a bit. Oh, we can just use it with Java under the Java package. But if we don't change it, we can just use it because it was licensed that way. So we'll just take those and we'll add all those features that are used in the modern application. Like, for example, tracing, open API, REST client, health checks. So everything that is needed in the modern cloud applications. And that's how Microprofile happened. And to make whole situation even a bit weirder, after Jakarta EE did all the due diligence that was needed to be once again on the freely modifiable Jakarta package, they decided they also want to create something for the modern developers and created something that is called core profile. So from situation where we didn't have any standard for the microservices, it's the first time I use that word today, after an hour, so I'm proud of myself. So they didn't have anything for microservices. Now we had two standards, microprofile and core profile of Jakarta EE. And for a time being, it was a problem what we should do with that. However, at the beginning of last year, of this year, if I'm, oh my God, I don't remember, of last year, at the beginning of 2023, they decided that probably microprofile will be just a superset of Java core profile because there were some additional parts they didn't have originally, but they decided, okay, we'll just add on that layer of core profile, and those two are totally compatible with each other. Okay, next step, Microsoft loved Java. Let's return to my favorite image ever, because it's help us to learn to understand technological landscape like none other. Because like we said, we have Oracle there and we have Microsoft there. And Microsoft is pretty interesting company. Since today I'm a very proud owner of the Java at Microsoft sticker, because I was talking with their guys on the stand on the OP conference, because I was speaking on OP as well. So I was talking with guys there, and for years it was some problem with Microsoft because nobody liked them. Nobody was they were talking, it was told that Microsoft is unfortunately a company that is killing open source, treating it as a communist. It wasn't a company that open source community cherished. However, the situation is probably a bit different today because we are talking about multiple projects. We are talking about the Adoptium. We are talking about Jakarta. We are talking about the microprofile. What is a bit strange on that image? Yeah, each of those projects is supported on the Microsoft, on the, I would say, strategic member level or enterprise member level. So very lot of money is put into ecosystem just by Microsoft. What changed in the years? Microsoft changed because Microsoft originally was a company that wanted to have every technology that was in their ecosystem. So in the situation was when they first originally wanted to have support for Java baked into the Windows, they decided that they will create their own Java. And they went to court with Sun. Sun said, okay, it's not allowed because they wanted to change some APIs to make it compatible with ActiveX. So Sun said that they were breaking the ecosystem. The court agreed. And Microsoft decided they need to do something with that and created language called C#. So C#, when we are talking that C# is Microsoft Java, yes, that's at least partly true. However, today the situation looks a bit different because Microsoft is not the company that is Windows-based, it's cloud-based. And when we have cloud, we want cloud to be we want our cloud to be accessible to everyone. For example, Microsoft a few years ago was the bigger contributor to the Linux kernel. And they are also involved with the Java ecosystem to make Java works in the best possible way in the cloud environment. For example, Microsoft has its own version of OpenJDK optimized for the Azure runtimes. And my favorite crossover episode that I have ever seen is that they were one that when the original M1 CPUs from macOS were created, this is new architecture based on the ARM, and there wasn't Java for that. You know who created the first official? It could be run as an emulation, however, there wasn't native one. You know who created the first version of native Java for macOS computers? Microsoft and Azure. So Microsoft were the ones who committed the changes to make Java works natively on Apple CPUs. If this isn't crossover episode, I don't know what is. Okay, one level deeper. As you see, we are going quicker right now. And it will be probably the quickest one because we'll be talking now about the two frameworks at once, Quarkus and Helidon. Have you ever used those two? How do you like it? They are very good, they are very modern, because I still remember times when there was Spring and nothing else. Now it's the Spring and a bit of some other technology, because Spring is still the most popular solution. However, we have currently Quarkus that is getting more and more traction. It's very, very good framework, and Helidon, and also microprofile. So we have a bunch of the modern Java frameworks that are using all those features that I was presenting to you. So because, for example, Quarkus was the first, okay, I don't want to use the word first, however, the first popular framework that was created in GraalVM in mind. So they were already prepared from the scratch. They decided, okay, we'll be able to run on the GraalVM in times when Spring couldn't even thought about being run on the GraalVM. Because GraalVM has some problems with reflection, as everything needs to be binary. They don't have class path. That's probably pretty interesting, important feature that I didn't mention during the GraalVM, that there are some drawbacks. They are not dynamic properties of the GraalVM. There are no dynamic properties of the application. No, there are no dynamic properties of the Java application. So, for example, we cannot get classes that are not available in the final package. And GraalVM, whenever are doing any compilation, they just get rid of everything that's not needed, because they are creating very slim binaries. And To make it run, for example, with reflection, we need to create proper whitelist that will mention, okay, those files will be necessary in the runtime through reflection mechanism. Quarkus was creating that list by ourselves. So we didn't need to do all that heavy bidding. Quarkus was doing that by the framework technologies, because it was created the way that it was possible. So this is Quarkus. Quarkus is supported by Red Hat. It's a very good framework. We have also Helidon. Helidon is created by the people in the Oracle, and this is the most experimental of the Java frameworks probably, because as people who are creating Helidon are in the close communication with the people who are creating Java, so all the new features are tested with them. And Helidon, like I already mentioned, is the first framework that is fully supporting virtual threads, and created version Helidon Nina that is that is running just on virtual threads without any additional new abstraction or byte buffers inside that, just standard virtual threads. They get rid of the netty, and now currently they are using virtual threads. So both of those frameworks are using GraalVM. Both are compatible with microprofile. Not entirely, but this is probably a topic for another story, because like always with standards, there are small differences. However, those two are working with all those modern stacks. So everything that is modern probably can be found with Quarkus and in Helidon. I suggest you to use Quarkus. What is interesting, have you ever heard about the Micronaut? Micronaut is also currently developed by Oracle. I even asked the question why they are developing two frameworks, and they said that Helidon is experimental and Oracle microprofile is something that people should use in production. So we have currently 3 frameworks like that. However, Micronaut is the best known of them all. Yeah, I think. Currently, Quarkus is probably taking the edge. To give Spring a bit of the truth, they are also doing a lot to be able to support virtual threads, to support GraalVM, to support all the modern standards. However, they have a lot of legacy that is taking a bit more from them. Still, in the last year, there was published, it was in 2022. We have 2024 now, so last year was 2023. So in 2022, there was Spring Boot 3.0 and Spring Boot 6 version that was fully supporting GraalVM. Because for Spring, it was pretty heavy because they are reflection-based. Like I said, reflection is not something that GraalVM likes. So for Spring, it took some time, but now they are also ready to support GraalVM images. I don't know how they compare with the Quarkus, Helidon, other stuff. Probably is a topic for pretty interesting presentation. However, they are there as well. So that after the long project of Spring Native, they catch up to the rest of the ecosystem. Yeah.
Just on a side note, I apparently know how they are compared because we are using both Spring Native and Quarkus, and it feels like that it's a bit smoother with Spring Native to build native applications. Probably also because we are Spring developers by default, and that is just where we like to live. But yeah, I used to work on last year on 2 projects, one with Quarkus, one with Spring Native, and the later gave me a better impression. Yeah, because Spring catch up, and Spring is in a very good shape once again. It's not that they are laggards behind all the community. They are once again, I would say, on the top. I think that Spring is, for many projects, Spring is the best default. However, for some projects, I like to use Quarkus. Because just for the experimentation bit and the fact that they have this extension ecosystem that for some use cases and some integration works very well. Okay, so everything have what they need. Spring is currently also a good framework and modern one. Okay, we are going one level deeper, and this is probably the part that got old the most in that presentation, because we are talking about the Java standard for the LLMs, when they Java standard for the machine learning from the times before the LLMs, and now everything changed because everybody is the most into LLMs. However, Java also is trying to go into space, go into that space, and like Java, because like we said before, Python is probably the standard for machine learning, and every language wants to get
a bit of that ecosystem, Java as well. And they were quite worried that, you know, even that thin layer of Python that was, like Python is just layer over C. Everybody was hyped about Python, everybody wanted to switch to Python. Probably it's time to do something with that. And what Java did whenever there was time to, you know, go to some new uncharted territory, they created standard. And that standard, original one, was created Visual Recognition API, because that's what ML was used in 2022 for, not for creating, you know, long pieces of text and the whole books and research papers. And this is standard JSR 381 Visual Recognition API. It is based, is a standard API for basic machine learning, for basic machine learning, image classification, object recognition. We have standard like that in Java, and it's based on the project called DeepNet. We have Deep Java library that was created by Amazon and is supporting the standard, so we have already 2 implementation. And it was pretty fun that when Java created Tribuo, their own library around Java 16 or 15, something like that, they decided they want to go into machine learning space. They created Tribuo. It's probably already dead. I need to check that. However, it was library for Java from Oracle for machine learning that didn't use the JSR standard. So they decided to go totally different way. Yeah, probably today there is a lot more projects like that, and this is once again topic for the another presentation, because the machine learning in Java is much more popular right now. We have LangChain4j, we have Spring AI, we have semantic kernel for Java, we have many projects that are they are supporting LLMs and all coming with that, all that models, and probably next time it's worth to mention it as well. However, it's time for another story. Once again, maybe we'll have opportunity in the future. Okay, let's go to yet another project Lanai. Do you have Mac users on in the room? Have you used M1 laptops? How do you like them?
We don't have any other options, like a future you can like.
Still, how do you like them? They are wonderful. For me, probably the most funny part is the fact that whenever I'm going to the office, I'm not taking my charger anymore, because they have enough juice to just run me through whole day. Even if probably not if I have too many meetings, because Google Meet is just stealing the battery, as there's no other. Like I said, no compiling is taking that much battery as, you know, Google Meet, unfortunately. However, they are very efficient and very powerful, and I like them. I'm not selling you anything right now, I'm just saying I like them. But there is quite interesting problem happening with that. Because, you know, with M1, Apple decided to totally switch to the project that is called Project Metals. And Project Metals is their special graphic engine API that was initially created for the iOS and iPad OS and their ARM processors, the CPUs, to like you see, to work, to be quite efficient for displaying things on screen, whatever is graphics or user interface, in the machines that have ARM processor CPUs. And when we are talking about the tablets and mobile phones, that probably wasn't a problem. However, now we are living in the world that the most of the Apple machines are powered by the ARM CPUs. And they didn't create they currently have a version of the OpenGL for that. However, they say that it won't be supported in the future. And you know what is using OpenGL to write stuff? Java. And the problem was that all the swings, all the AWTs, all the other frameworks that were used to paint anything on screen were using OpenGL. And there was a big risk that Apple in the future just will get rid of that of support for Metal. And Java will be not ready for that. And probably, who is writing desktop application for Java? Nobody, as you see. So you probably shouldn't care about it, yeah? But you know who cares? Those guys, because JetBrains IntelliJ IDE, so the stuff that is probably used by many of us, and many of developers, and is backbone of the JetBrains business, at least I assume so. It is powered by Swing, and there was big risk that unfortunately in some not that distant future, because you never know with Apple, there will be in one of the version of the macOS there won't be support for OpenGL, just for the metals, and probably it will be big problem for the companies like that. So JetBrains, with the cooperation with Oracle, they initialized, because they are the ones who cares, they created Project Lanai that was allowing migration of the whole Java Visual Toolkit to the Metal standard. So Metal is currently supported by Java as well. They are the ones that also create a lot of different desktop applications with all this Kotlin multi-platform approach. For example, they have Compose for desktop, for a whole UI toolkit to create the UI components for desktop on the all operating system, on web as well. And for time they will create Skija, so port of the Chrome engine to the Chrome graphic displaying engine. I'm not the professional there. However, the one that is used to write everything in Chrome to the Java. However, that one was dropped. So in that case, they didn't care that much. And to show you what could happen in the future, I realized last year, because I'm the gamer, and last year I was trying to play one of the custom games. StarCraft is my standard winter tradition during December when I'm going home for Christmas. I'm playing StarCraft with my brother, and we wanted to play the custom game. Have you heard about StarCraft? Probably you heard of StarCraft. It's a pretty popular game. Yeah, and I wanted to use the custom games that is using their editor when StarCraft itself is working on the M1 processor, CPUs. Unfortunately, there is information, whenever you're trying to run the editor, there is information that you cannot do it because the driver is not supported. Unfortunately, is that something that could happen in future for the JetBrains IDE? Unfortunately, we dodged the bullet as the community, because currently the support for Metal is also available in Java through Project Lanai. Okay, we are nearly there, because just 2 layers. So we are probably wrapping the whole presentation. Now we'll be talking about the Project Leiden. It's Project Leiden, not Project Leiden, sorry for the typo there. And the goal of Project Leiden is to improve runtime, the time to peak performance of Java written programs. And what does it even mean in practice? In practice, for years, its program was run, and there was different initiatives around that project. For example, writing ahead of time compiler in Java, so something similar to GraalVM. And for years, people didn't know what even Project Leiden is about. So Mark Reinhold, one of the chief architects, one current chief architect of the OpenJDK, decided that he will explain everybody what it is, and did that in paper Selectively Shifting and Constraint Computation. So nobody have never read it, because nobody is reading papers like that. However, it's probably worth it because it's a very good one, and it's explaining what changes will be happening in Java in few years. Because, like we already mentioned, currently our application, most of the time, are run in the way that we have our application. It's run in the Kubernetes, and we can currently, for example, compile with its ahead of time application. However, it's not something ahead of time compilation, like with GraalVM. I will explain you the process. However, it's not something that will work for all the application. There's not one fits all way to distribute Java application, because you need a bit different runtime properties if you are compiling something to auto-scaling environment in cloud. And you can, for example, use GraalVM, or so you have access to serverless application. The startup of the application is very important to you. There's a bit different requirements if you need to support old applications that have class path, that has a lot of external dependencies. We are not able to create a GraalVM image or any image. So this is a bit harder in that situation. That's why Project Leiden had a very insightful idea. We probably shouldn't make the one-fit-all environment. We probably should allow developers to create their own using standard, blocks. And this is an example of Project Leyden. Project Leyden decided to split Java runtime process into 4 different phases. The first one is compilation phase, so we are compiling our application. The next one is class data sharing generation time. So there is a run process application class data sharing. I was describing it during my last presentation. I don't know if you remember, it was one of the stuff that I was describing when I was in the November. You have a linking phase that is connected to modules. Nobody is using modules, so nobody cares. Is there anybody who is using modules? Okay, I thought so. And we have runtime. And in runtime we have JIT, we already described JIT, and we have project crack, we will describe project crack. All those phases are separable, and application can use just a handful of them. For example, if we want to have application that would be fully optimized, is optimized for the very quick start, and we are okay with, for example, because like I said, JIT is better, so it's able to optimize more aggressively. GraalVM can also optimize a bit more aggressively, however, it needs some additional features, most of the time Enterprise Edition. So we can say that if we are using standard GraalVM, we probably should, we achieve around 80% of the JIT power, JIT performance. Still, it's fine for the application that run for 10 seconds like serverless, or we need to auto-scale it on the Kubernetes. So in situation like that, we are able to just compile that application ahead of time. Application is compiled, and no other phase is interesting for us because here we are receiving the final binary. But we can, that's not the case for all the applications. Most of the Java applications are still running the way that we are creating jar, putting it on the server, it's running there for a week or maybe even more. So probably that minute or two that is needed to fully warm up JIT and make applications fully efficient is probably enough. So for that application, probably ahead of time compilation is not worth it because maybe they are using the class path, so it's not worth to change anything. We can just go with the standard process because we will be using standard compilation, not ahead of time compilation, but standard compilation to bytecode and JIT. So everything that was available, we can go as we were going, as our grandparents are going in Java in the 19th century. Yeah, everything exactly the same. And all those blocks that were presented will be part of the Project Leyden are called condensers. Each of those, we can compose them in any way we want. So we do not need to just select all of them. We can decide which will be necessary for our project. Currently, some kind of the abstraction for that code application model is created, and it was published last year during, and is currently under the feedback. However, it will be possibility to just create binary in one step and pass it to the other because there will be abstraction connecting all those steps. Something that will be the backbone for the whole project. It's called condensers, and if you ask where is the place for GraalVM in all that, GraalVM will be treated as yet another condenser. At least if it will become the part of the OpenJDK, and that's probably because no hard decision made yet, but probably it should be treated just yet another condenser. And it will, through that, it will feel quite well into the whole OpenJDK ecosystem. Okay. And as we already told about the GraalVM, we'll once again return to the topic with something that is very, very, very interesting. However, do not even think of using it on the production. Because we are talking about the Espresso. And what Espresso is all about. Espresso is all about, to understand what Espresso is, we need to understand GraalVM runtime process a bit better, because like we said, that fact that we have JIT compiler is something that we most commonly used. However, GraalVM for quite long time was good. We could use GraalVM in the compatibility layer with Java, so we could just run Java, make it to run standard Java programs after Java runtime. How in the Java runtime, using just GraalVM JIT compiler that had its own properties, it was possible. However, truffle languages, so all those languages that were created and distributed as yet another package in Maven, they were a bit different story. Because it was possible to do non-garbage collector languages. I know that JavaScript is garbage collector, however, it was created, there are versions that are none. So the languages that don't have garbage collector are easier, and not garbage collector, however, having particular specific, not that complex garbage collector like Java were possible to do with Truffle, but for years it was not possible to create Java runtime and Java just-in-time compiler, standard one, with Truffle. So with framework that I was allowing to write Java language, different languages for the GraalVM. And for example, we are able with Java 8 use runtime for the Ruby because it was Truffle language. Truffle interpreters are just standard jars that can be compiled to the JDK 8 compatibility level, and we can use, for example, Ruby there. It wasn't possible for Java yet, because there was a project that was called Express. So it's quite old project because it's from beginning of 2022 or even older, and its goal was, is it possible to write Java, the runtime that can be run as a Java jar? And it's so-called meta-circularity. It has proper name. It was, I would say, moonshot that community wanted to do, and they achieved that. So currently, Java can be run as the Java runtime can be run as a Java application. And with that comes pretty interesting feature. Because as I said, you can run Ruby as a jar that can be run by the version of Java 8 on the Java and runtime. However, through Expresso, you are able to create, for example, Java 11 that will be consumed as a jar, that will be run on the Java 8 application, and then you will be able to just run your Java 11 program with JIT compiler of Java 11 that will be run on Java 8 runtime. If you think how to use it, if you have, for example, cannot have newer version of Java in your machines, and you have access to just use any dependency you want, I'm not suggesting anything. However, it's currently something that is possible. So currently Java can run Java, and it's pretty amazing. Okay, we are going to the last level, so we are mostly done. The first one of the projects we'll be talking about on that last level here is project Lilliput. And this project, once again, is touching very, I would say, deep level of the Java engine, because it's talking about the object and object headers. Because every object in Java needs to have some meta information. Those meta information are stored in so-called headers. And those headers in Java object are 128 bits. No matter how big is the object, how big needs to be header. Whatever we are talking about, small string or very big object. As we said during the project Valhalla, whenever we are creating Java object, we are probably creating multiple Java objects that will be stored in the heap somewhere. So finally, those headers are taking a lot of space. And there is idea, maybe we can reduce, because Java is known for the fact that it's using a lot of memory, maybe we can reduce that by reducing object header. And currently, the first step of that was that people in the JDK community were able to split the part, because there are two parts. The first one was for the class pointer, so pointer to the object. The other one was for the information for garbage collector, log, identity, things like that. And the first initial step was to reduce that part to 32 bits. So our hash codes will be smaller if we use specific lag. So we are just squeezing our headers, because current research shows that we probably do not need so long hash codes just to receive the individual identity of the object. We can have something a bit smaller. Currently, okay, so it was 64. Currently we have smaller class pointer, so class pointer is smaller, and we are currently fighting for taking that part of the identity, because previously it should be 64. However, there's some problem with that. Unfortunately, we are touching, and final reason why it should be 32 bits for class pointer. That is already available when we are using special JVM flags. We can use that on production. However, the next goal is to have 32 bits for garbage collector, lock, and identity. And that is pretty risky currently, and that's why this project is taking a lot of time, and this is probably the first job I don't have this job, okay, I don't have this job here. This is probably the first job I have ever seen that consideration part was far longer than any other part of JEP. What we need to be careful about, because we are touching everything there. We are touching how the garbage collector works, how optimization of memory works, how other project works, because like I said, Valhalla is quite involved in that. And for example, that space that was already saved from the headers, probably Valhalla would like to use because they want to preserve information about nullability. Still, Project Lipu is very interesting, especially if Java wants to go to the new uncharted territories, like for example, as I said, machine learning, because in machine learning you are creating a lot of different objects that are pretty small, but you have a lot of them. So you need to have ability to create small objects. And last but not least, Project Crack. And Project Crack is not what you think right now. Project Crack is project coordinated restored at checkpoint, and this is yet another approach to make Java start much faster. Project Crack, like I said, this is the last time we are seeing that wonderful diagram when we have bytecode interpreter, just-in-time compiler, and compiled code. And as we mentioned, just-in-time compiler is wonderful, it's giving us very efficient code. However, it is very, very slow. It's slow on purpose, because just-in-time compiler, as I probably mentioned today more than once, works in the way that if we have our application running on production, it's checking, for example, if given method is used, if it's used for multiple parameters, it can do very aggressively, we can compile application very aggressively based on the dynamic profile of how application is used in production. However, it takes time, because it needs to take time, because it needs to learn how application is truly used. We sometimes try to speed that up with a process called warm-up. You probably heard about technique, that if we want, for example, make application start, we are just running smoke test or something to make it faster. However, there is one interesting idea, because probably in the most cloud environments, if we have, for example, 10 instances, each of the instances should have exactly the same kind of load. So it should behave the same way. Maybe we can cache something there. And this is where Project Cracks comes in, because do I have any retro gamers there? Yeah. Have you ever used emulator? Do you know the feature that's called save state? And save state is the feature how we are saving games in such an ecosystem. Because when we have modern games and that are using, for example, 8 GB of the memory, it's not feasible to have it each time whenever we are creating save, just be written on the hard drive. I still remember games like Deus Ex that on my 40 GB of drive where I have 1 GB saves, because they are doing exactly that. However, currently developers are a bit smarter, and what they are doing, they are just having that discrete set of the parameters that allow them to restore the whole game state using limited set of the information. Not the whole memory that is stored in the process, but something smaller. It's something that is not worth the hassle with the older games, because, for example, for the Nintendo Entertainment System console, that was 8 kilobytes of the memory. We can freely save it to the drive and restore it from scratch whenever necessary, hold the set of memory. And this is how save state works. They are just taking the memory of the process and saving it to the disk. And this is a bit like Crack works. Because what Crack is doing, Crack is, whenever JIT compilation is done, Crack can be triggered, Crack process can be triggered, compiled code can be cached on the drive, on the S3, on the any blob storage. And whenever we are starting new application from scratch, we can just decide not to do all that time-consuming just-in-time compilation phase. We can just use our compiled code. It was the project that was initiated by Azul, and What was probably the interesting, and I missed that when I first heard about it, is that Amazon was very interested in that project, and we learned why during 2022 presentation on the AWS event, so the yearly annual conference, when they presented Snapstart. So they integrated Crack-like process with Crack-like API into their AWS Lambda. So Lambda can be optimized exactly that way using just one single fract in the YAML configuration, because they are doing all the stuff with initialization, and they can then cache all that stuff because applications that they load, and all those Lambda functions can be spawned from the particular point in time. What is the problem with that? If we just preserve state of the memory after JVM started? Randomness. Because at the beginning of the creating Java virtual machine process, we are creating randomness. And unfortunately, there's a problem that we can, break all the security features connected to the having different seeds for different applications. Amazon, for example, in the Corretto, so their version of the OpenJDK, they rewrite version of the secure random, so they is crack aware. However, if any of the dependency will use standard random, probably it will use exactly the same seed for all the processes. There is some bit different problem like that with crack. Still, it's very, very interesting development for the whole ecosystem that is probably a bit more lightweight than what we need to do to run our application, start our application faster with GraalVM. Okay, that's all. I hope you are alive, because how much it took? 1:45. So it was pretty long. I hope you are still alive, like I said. And I would like to thank you very much. That's not important anymore because this project is not that well developed. However, I would like to invite you to my newsletter, because I am creator of the weekly newsletter. When I'm describing all that stuff I was talking about you today on the weekly basis, when I'm trying with a bit of humor present everything that is happening in the JVM ecosystem. And now I would like to thank you. If you are still alive, like I said, if you are still alive after this nearly 2 hours. I am ready to talk through the rest of the evening. I'm more pumped than I was when I came here. Sure thing.
Is there a risk of SQL injections increased with GraalVM? Because you told something about JavaScript code that is.
It depends. It's embedded. It's embedded into the Oracle database, so it's in the engine of the database in that situation. So they are just used. Okay, you can write a piece of JavaScript and run it. For example, when you add another row to your table to do some action on your database. So it's purely internal. So there is no options for the user input there.
So it's more for stored procedures?
Yeah, it's exactly for stored procedures, yeah. Stored procedures, but stored procedures in JavaScript are run on Oracle database through GraalVM. But they don't have access to user input. The only way I imagine it's possible to have any SQL injection is if the data that was put into database aware what trigger is doing and doing something shady there. However, probably it would require a lot of internal knowledge. I don't see other surface attack there. Another question.
Can you give a short just-in-time versus ahead-of-time explanation?
Sure thing. Okay, it won't be short. However, I hope it will be interesting. Okay, just-in-time compiler. Just-in-time compiler is working in the way that whenever we have application, we are putting our application, like I said,
The global standard is the just-in-time compiler.
Just-in-time compiler, okay. And ahead-of-time compiler. And when I remember learning programming, when I was learning C++ programming from the magazine that I bought because I'm from the countryside, and in countryside I bought a magazine in the grocery store that, teach yourself a bit of C++. That was my first time with the programming, and the true story. It wasn't C++ even, it was C. I probably never imagined that we'll be talking about the just-in-time compiling, ahead-of-time compiling. Just-in-time compiling, for me, compiling was compiling, creating application from source code to the binary format that can be run by program. When we started to have the virtual machine, the outlook changed a bit, because now we are talking about the intermediary first. So we are creating the first, in Java compilation is not compiling application to the machine code, but to that intermediary representation that is bytecode, and then just-in-time compiler is compiling parts of it to the machine code. So we have two steps of compilation. Ahead-of-time compilation can be treated as the standard C compilation that, whenever you are C compiler, you C developer, you are doing ahead-of-time compilation. So in the one step, you are changing application from the source code to the binary format. However, because there are some caveats with that, just-in-time compiler, like I said, it allows to have a more aggressive way to optimize application because it knows how it will be run on the production. Ahead-of-time compilation, in approximation, is giving us, in the naive version, is giving us application that is around 80% of can be achieved with just-in-time compilation with GraalVM Community Edition. However, yet again, side note, Enterprise Edition has very interesting feature that is called profile guided optimization. So they are able to run application in JIT mode, optimize it, learn what should be optimized, save it for later, cache it, and then when we'll be compiling it once again and nothing significant will change, we are able to just compile that application with all those information from production, and it's trying to deduce what can be, actively, it's hard engineering, that's why it's in the Enterprise Edition, however, it's possible. Yeah, so just-in-time compilation and ahead-of-time compilation currently in GraalVM, if you use Oracle GraalVM, so late Enterprise Edition, are on the same level. Even some Oracle benchmark says that GraalVM is better, and there is one very interesting challenge, like I said, 1 billion row challenge that was essentially pretty viral in the community, that results are happening right now, and we will switch to the stream just after I stop talking, because I wonder who won, finally. There will be people, there will be, for example, creator of the GraalVM on stream and Nikolai Paralog, who was your guest last time, if I remember correctly. They will be on stream presenting that. And to show you, because the challenge was working that way. We have 1 billion of rows. We want to process them, aggregate them as quickly as possible in Java and check who is the quickest. And the fact is, all 6 or 7 first results were on GraalVM, because GraalVM is that blazing fast. Yeah, it's faster than anything other we can do with JVM currently. Oh. Question?
Are there any innovations regarding good graphical user interface, or is it a bad subject?
This was the first one. We started with the user interface and then focused only on the virtual machine, because that's my cup of tea. Sorry for that. I hope it was still interesting. Yeah, this was records, Project Amber, things like that. It was the Project Amber, we started with that, and then we truly went deeper. Yeah. So that, yeah, everything that is happening in the user interface, it was probably covered in the multiple presentation there. Yeah. All those changes. If not, I'm happy to do one like that as well. I just skimmed through that, unfortunately. That's why it's called Under the Surface. Okay, so this is probably all.
Thank you very much, Artur.
Thank you very much. It was a pleasure.